Hi everyone, this is Mohsen Ayoobi, an assistant professor from Wayne State University, and this project is conducted in collaboration with Sunita, Pokharel, and Dr. Akkerman from West Virginia University. The title of this project is Syngas Characteristics for Application in Microsatellite Thrusters and Unmanned Aircraft Systems. There has been an expanding interest in cutting-edge and small-scale and portable power generation devices for applications in unmanned aerial vehicles, microsatellite thrusters, and the need for advanced technologies with reduced weight and high durability. With regard to the higher energy densities of combustion-based resources compared to the battery resources, the combustion could be a good choice for such cases, but there is also the need for clean, green, and sustainable energy, where the critical need exists for an efficient methods to sustain such microcombustion systems. And here, syngas, which is a good combustion fuel that can create less emissions and combust better, could be a good choice. That's why in this case we are going to investigate syngas combustion characteristics at small scales. We are using a two-dimensional channel with a length of 20 millimeter and half width of 1 millimeter, a temperature gradient at the upper wall to to mimic the conjugate heat transfer at small scales. We are using detailed chemistry and also using the ANSYS Flow and commercial software to do our computational work. We are considering 3 different syngas compositions because syngas can exist in different compositions depending on the sources that are being generated, and also various inlet velocities ranging from 0.1 meter per second to 3 meter per second. And details about this work are available in reference 3 in the publication that we've had for this work. In this work, we are looking at the ignition process, how syngas ignites, depending on the syngas composition and the inlet velocity, how the ignition time, the ignition location, the ignition span is going to change. These are the things that we have investigated. Also, depending on the inlet velocity, we see different types of flames. Some flames are stable, especially at medium and higher inlet velocities. And for those, we see a flame igniting and then propagating upstream until it stays at some location and it stabilizes. For such flames, we investigate the stability. We investigate the flame length, the flame location, the flame span. And there are some cases where at lower inlet velocities, usually less than 0.2 meter per second, where flames go over a periodic ignition and extinction, and those are known as FREI phenomenon in the literature, which is flames with repeated extinction and ignition. For those cases, we have investigated this periodic behavior for different mixtures, how changing a mixture from one to another is going to affect this periodic instability, going from flame to no flame and then igniting again, things like that. And all the details again are available in the published paper. And if you are interested to learn more about that, please feel free to contact me and I'll be happy to provide more information.